Alright, so this is Blood Bank Help Part 2. So we're going to look at question number 6 from your Unit 2, Section 5 homework. And the question says, they stabilized your gunshot wound, but the ICU doctor is now requesting 3 units of cross-match red blood cells. After doing the antibody panel, you find out that your patient has, and I always like to start off with what do I know. So my patient has an anti-JKA as well as an anti-C antibody. So I'm dealing with multiple antibodies here. And don't confuse your big C's and your little c's. So, it says after that, how many O-negative units should you grab from the fridge to screen to find 3 that will be compatible? And I gave you the hint, I don't need to worry about determining compatibility with the O-neg because that's already given to me. It's written right there on the bag. So you don't have to do any calculations for O or for Rh negative. We assume that's already known because it's written right there. So what I need to do is find out how many of these people, or what the compatibility rate is going to be with JKA and big C. So we go back to what we talked about just a second ago, where we look at our antigen frequency charts. So I need somebody who's going to be negative for JKA. So from my donor population, and we kind of just looked at this at the beginning, I know that it's this 23% of people from the chart who have this phenotype or this pattern where they are A negative or JKA negative. So I know that the percent compatible with JKA is going to be 23%. Now let's go ahead and find it for C. So the big C, if we look at it here, I see that big C has a frequency in the population of about 70%. So the people that would be big C negative is the remaining 30% out of 100. So now I go back to this and I say, okay, 30% of my population is negative for big C. The thing that I got to remember when I'm doing a problem like this is that my population needs to be negative, or my donor cells need to be negative for both. So in order to find that, I multiply the two. So converting these to percentages, I have 0.23 times 0.30 will give me my percent compatible. So this is essentially finding how many people are negative for both of these guys. So I determine that 0.069, or if I want to turn that back into percent, times 100, tells me that 6.9% of my entire population is going to be compatible with someone who has an anti-JKA and an anti-big C antibody. So the step after this, that would be my percent compatible. The step after this says I need 3 units of these O-negative cells that have this pattern of being negative for JKA and big C. So all you do is just put the number of units you need over your percent compatible and you multiply, or you do the division there. Quick note before I do that, make sure that you're not saying, hey, 6.9% is 0.69, because that's the same as 70%. See, a lot of students will get a problem like this and they'll say, oh, I have a 2% compatibility, and then in their math I see this guy, 0.2 times, whatever it is, 0.67. Remember, 0.2 is the same as 20%. If we're talking 2%, that's 0.02. Don't get that mixed up or you'll miss these problems. So back to the problem, how many units am I going to need to screen to find 3 that are compatible? It's 3 divided by 0.069. And the answer is 43.47. I can't screen a half a unit, so we always round up. So in this case, I would need to screen 44 units before I was going to find 3 that are compatible. Which makes sense if you think about it. If only 7% of my entire population is going to be compatible, then it would take me a good number, 44 units before I found those 3 that would work.